Discriminated unions in Zustand. Why would you even use a discriminated union? Well, let me show you a real-world example. So here in my application, I have two tabs. So you can switch between the tabs where you are the lender. So here you can view all of the debts where you are the lender and the others are the borrowers. And then we have the tab for as borrower, which is the other way around. But all of this is persisted in Zustand. So if I come here, as you can see, I can filter by the status of the debt. So I can switch between all, active, recurrent, archived, etc. So let's say I switch to archived, and let's say I move over to the as borrower tab. As you can see, we're preserving the active filter. So even though we modified it here, this is still going to be the original one. But let's say I want to switch this to archived. As we can see, it was originally active, so that's the default state. But if I move back to as lender, it is now archived and the two are archived. If I switch this to recurrent, now this one is recurrent and this one is archived. So no, they are not being reset every time you switch back and forth. In fact, we're caching the values. So when we switch to the lender tab, we retrieve the cached values in the Zustand store, and the same with the as borrower. Now, where's the part for discriminated unions? Well, if I come here and inspect element, and then come here to the application tab, as you can see, I'm storing the variables, so the query variables in session. And here I have the key for that query variables, and then I have the state. And as you can see, we have the borrower query and we have the lender query. But if I take a look at the borrower query, we have the type to be as borrower. And if I come here to the lender query, the type is as lender. So this is where the discriminated union is taking place. It is switching upon this type. Now, the reason I have these two is again for the cache. You might as well just have one, just store one value and call it a day. But since I want to provide a good user experience, I don't want to make it so if you switch back and forth, the values are going to be reset. That would be very annoying. So currently, since I'm at the borrower tab, the source of truth for the query variables are these ones under borrower query. And this one is just the cached value. So I do not lose the state when switching back and forth. And lastly, we have the current type at the top level of the store. So this is the value that tells us which of these two cached values should be used. And that's pretty much it. Now let's take a look at the internal workings. So this is the input for my endpoint. So my endpoint receives this discriminated union. Now I'm using Zustand for the validation, but of course this doesn't matter. So here the discriminator is the type, and then I provide the two options, and then this will have the type to be as lender, and so it takes these parameters. So we have the skip for pagination, we have the status, we have the borrower ID, and then an order by for the sorting. And we do the same for the as borrower type. Now, when we extract this type, what we're getting back is this type. So as you can see, it is just a discriminated union. So it can either be the subject, where the type is as lender, or the subject where the type is as borrower. This of course lets me modify these parameters depending on the type. So on the as lender, we can view the status for pending confirmation, something we cannot do as borrower. So this is why I'm using discriminated unions. And again, I just export this type. Now what about the Zustand store? Well, this is where it gets interesting. So I define the two types. So I have the lender query. So again, this type right here, and then we have the type for the borrower query. Now here what you can do is actually separate or extract this schema into its own schema. That way you can export the type with this. All you need to do is say const lender schema is equal to this, and then export type lender schema is equal to sed.infer, and then you pass in the type of the schema, and do the same with the as borrower. But I prefer not to do that, mostly because of laziness. So for that we can use this helper type. So extract from T those types that are assignable to you. So here we can say extract from getUser.input, which again is the discriminated union, and then we can pass in the type. So this is going to extract the type for the data where the type is as lender. So this is one way we can extract the type for a discriminator in a discriminating union. And we do the same with the borrower query. So we get these two, then I define the setter. So this is so that I can update the state. This mimics set state from use state. So we take in the query update, and this will be partial of the input, or a function, so a callback function that passes in the previous state and we can return partial of the getUserDeath's input. So this is pretty much exactly the same as the setter function of a useState call. And then optionally, I can pass in the type. That's so I can override the data for a particular type. So this will be a union of either as lender, as borrower, or well undefined since it is not required. And then I define the actual store. So that query variables store, and we have the set query, so the setter, we have the set type, so that we can switch between types. So between the as borrower and as lender, then we have the current type, and then we have the lender query and the borrower query, which are the cached values. Now here I have the default values for the lender query and the default values for the borrower query, and we'll see why it's necessary to extract them. And then I define the actual store. So I use the create function from Zustand, I invoke it, and I pass in the generic so that it knows the types. And then I pass in the persist middleware. So this is so I can persist the variables in session storage. And then within this middleware, I pass in the callback for the initializer. So we get access to the setter and the getter from Zustand. And then here we can define the initial values for the store. So lender query, default lender query. We do the same for the borrower query, and then the current type to be as lender. And then I have the function, so set type, we take in the type, which again is this union, so the discriminator, and then we set the current type to be the type. And well, with Zustand, the setter by default lets you pass in partial of the data. That way you do not have to pass in or spread over the previous values, which is great. And then we have the function that I defined, setQuery, which is basically a wrapper for this raw set. But since we need some logic here for handling the cache, I cannot expose the raw setter. So here we take in the query update, which again is pretty much like set state. And then we have the type, which is optional. So here we have const target type is equal to, and then we check, did we pass in a type? If we passed in a type, then take it. Otherwise, we use the nullish coalescing operator, which is going to default to the right-hand side if the left-hand side, so the type, is undefined or null. And with this, we can call get, and we get access to the current type, which is this one. And then const target query is equal to target type. If it is as lender, then we get the lender query. Otherwise, we get the borrower query. And this is so we know which to update. So based upon which previous values. So here we can say, is the query update a function? So are we passing a callback function? If so, invoke the query update and pass in the target query. And we know this is going to return partial of the data in the store. So we invoke it, we pass in the previous state so that the caller can get access to the previous state. So again, this is mimicking the set state. And if not, well, we just spread over the target query with the query update. The reason we spread them over is because we want to provide this interface, or rather this behavior, where you can just pass in a single key and value, and it is only going to update what you passed in, instead of actually setting this store to just be an object with one key and well, one value. So that's why we spread them over, which are going to be replaced in the case the query update contains them. Pretty straightforward. And then we check if the target type is as lender, then we set the lender query to be the updated query. Otherwise, we set the borrower query to be the updated query. As simple as that. Now, if you have a discriminator that is not only two values, such as in my case, well, you can just use a switch statement here and handle everything accordingly. Now let's take a look at the magic for the cache. So here I pass in the name of the store, so the key value in the session storage. I pass in the storage, so create JSON storage, and then we can pass in the storage, so either session storage or local storage. In my case, I'm using Next.js, which is going to be executed first in the server. So since session storage and local storage are not going to be defined in the server at first, before, well, it gets hydrated in the client, I need to pass in this function instead, which is simply going to check if it's in the browser. If it is running in the browser, take in the storage that I pass in, so window.session storage or window.local storage. Otherwise, just return dummy storage for server side, basically. And then we have the version. This is very important so that when you introduce new fields or you change something up in the store, if someone has outdated data in their storage, well, Zustand will know that it differs from the one that they have. And so it is going to basically replace everything with the default values, if I'm not mistaken. This is the default behavior, although I'm pretty sure you can provide a function where you can handle each case accordingly per older version. You can check the documentation for that. And then we have the onRehydrate storage, which is a function returning another optional function. The main function will be called before the state rehydration. The return function will be called after the state rehydration or when an error occurred. So this is when the user first loads the application. Well, Zustand will use this persisting middleware to check for data stored in, well, either session or local storage, and it is going to retrieve them to populate or initialize the store with those values. So this is a function that you can pass in so that you can maybe perform some validation after rehydration or whatnot. So here what I do is return this function. So again, this function will be called after state rehydration or, well, if an error occurs. So here we get access to the state after rehydrate, which is that query variable to store or undefined. Now this is not entirely true, and I believe this should be unknown, and the reason is because in Zustand, at least with the current implementation, and from what I've read from the documentation, it obviously does not validate the data beforehand. And here we're not passing an extension, which is a sort validator, and we can pass in the schema so that we can guarantee that the data Zustand is reading from the storage is indeed of this type. So here I use sud to make sure that we get the data in the shape we wanted. So here I say const store data is equal to get user.input.saveParse, and then I pass in state after rehydrate. And well, sud will check against the schema. If it is not successful, then that means that most likely someone tampered with the stored data. So I just set the query to be the default lender query, and then I pass in the type to be as lender. And if not, so if it is successful, then I get the data, the type, and if it is as lender, then I just set the state.lender query to be the stored data.data. Otherwise, I'm setting this to be the default lender query, which is redundant and actually will never reach that point due to this condition. Now you might be wondering, why am I repeating the stored data.success? And the reason is because TypeScript for some reason cannot infer that with this class guard, success is now true, so we can get access to data. So I still need to say if stored data.success twice for these two cases. And that's pretty much it. This is the whole logic. But what about consuming the store? Well, the problem is, since we're using discriminated unions, that means that every time we subscribe to the store, if we want to get access to the lender query or the borrower query, you need to switch upon the current type. So you could use a ternary. So you could say store.current type is equal to as lender. If so, we get the lender query. Otherwise, we know that the current query is the borrower query, which becomes very tedious and also error prone. So for that, we can use Zustand selectors. So what I did was define this selector, select current query and setters. So here it is going to internally take in the state from the store. So as we can see, that query variable to store, and it is going to return an object which contains the current query, and it is going to check the current state, so the current type. If it is as lender, then return the lender query, otherwise return the borrower query. And all of this leaves behind this current query. And then we have the set query and the set type. So this is what is actually exposed to the consumer. So we can say use that query variables, and we just return that query variables store, and we pass in the selector. So as we can see, state, extract the state, and we pass in select, current query, and setters. So now let me show you how you can consume it. So here in the tabs, I subscribe to the store with this hook, which returns again the current query. So this is a union, of course, since the type could be as lender or the type could be as borrower. And then to set the query, all we need to do is say query variables dot set query, and then we can pass in the value to be updated, and the same with the set type. So here I have the query variables, I have the selected type, so this is as lender or as borrower, and then when I click on each tab, so here on the tab as lender or on the tab as borrower, all I do is take in the new type and then set the type to be the new type, which again is going to invoke set, and we pass in the current type to the new one. And this is how we can get this behavior, so everything is perfectly synchronized, and as I switch between different data in the store, so due date, and switch back, it is going to retrieve the cached data. Anyway, this now wraps up the video. If you want to see more content like this, make sure to subscribe and like the video. I'll see you in the next one. See ya.